Now, from the configuration point of view, you configure the NTP server feature on the iOS, which means NTP master. So you're going to define the router to behave as a time source, NTP master, and then optionally you can define the key to be used for authentication, and you have to configure that key to be trusted. So on the NTP server, you just the only required command is NTP master to define it as an NTP authoritative, let's say, time source. But then authentication is optional. So if you want to authenticate the NTP traffic, then on the server side, you just define the key with the key number, the algorithm of MD5, and then the key string, and then you configure that key number to be trusted. On the NTP client, if you want authentication to happen, then likewise you have to configure the same authentication key number as on the server and the same key string, because both the key number and the key string are going to be used as inputs into computing the MD5 hash, which is going to be attached to the NTP packet. Like on the NTP server, you then say NTP trusted key and the key number, and you have to say NTP authenticate on the client. So if NTP authentication is not required, on the client we just need to configure the last command, which is NTP server and the IP address of the server. You don't have to configure the key number. You have to put the key number at the NTP server command only if authentication is enabled, and at that point you also need the above 3 commands on the client side. Now, if you look on most documentations, they put in there the NTP authenticate command on both the server and the client, which is one of those use cases that's just wrong, because the NTP authenticate says I want to authenticate the NTP packet. And just think about it. The NTP client wants to authenticate the NTP server in order to make sure that the time being received is received from the proper and correct NTP server, so that the NTP server is not being spoofed. So it makes sense that you want only the client to run the command NTP authenticate, because you want only the client to authenticate the time source. The server doesn't need to authenticate the clients, because the clients, they don't offer time to the server. So that's why you don't need the NTP authenticate command on the server, only on the client. Otherwise, the other commands are pretty basic. As long as you know that you're doing NTP authentication, which supports only MD5, then the command is going to be NTP authentication key, key number, MD5, key string. Then you got to make sure that you trust the key. The NTP trusted key command was added by CISCO as a safe mechanism to make sure that, you know, if accidentally you configure on the router multiple keys, then you have one more command to actually validate that key as being usable, because you trust the key by NTP trusted key command. And then when you define the server, you say NTP server IP address, and you specify what is the key number, because if you don't specify what is the key number, then the client doesn't know which key string to use to communicate with that server. So all commands make sense if you just take time again to look at those commands, and you don't have to memorize those commands. Likewise for syslog, likewise for pretty much any technology, but I'm not going to be able to perform this kind of instructions for all technologies. Verification steps. Because NTP synchronization between client and server may take time, it all depends on how big is the difference between the client and the server. Because the bigger the difference, the more time it's going to take for the client to get synchronized. Because time being synchronized is time synchronization is going to be done incrementally, is not being done in one, let's say, single packet. So if the client time is, let's say, 6 p.m. and the server time is 10 p.m., it's a difference of 4 hours. This will not, the client is not going to update its time instantly upon the first receipt of an NTP packet from the server. This is being done incrementally based on a lot of, let's say, variables behind the scenes. So it's going to take time. The NTP synchronization is going to take more time if the gap between the server and the client is big, and also especially if you run on older platforms that they have, let's say, older hardware clocks which are going to be working differently behind the scenes. To verify NTP synchronization and authentication, you have two commands: show NTP status and show NTP associations, or also show NTP association details. So before we go to the configuration side, let's see if there are any questions. Okay, not. Let's move on then. So what I'm going to be doing is I'm going to configure in my use case. I'm going to make router 2 to be my NTP client, and router 1 to be my NTP server. I'm going to begin with unauthenticated configuration just to confirm that synchronization works. So on the server, you just say NTP master on router 1. Let me remove from router 2 that ACL from there before we move on. Okay, now let's go on router 1 and make this an NTP server, which by default it is not. If you say show NTP status, it says NTP is not enabled. So NTP master, and if you say show NTP status, it's going to tell you that the clock is being synchronized. I'm using by default a stratum level of 8. This may be different between router to router. The stratum level can be changed with the NTP master command. You can say NTP master, let's say 6, for example. So show NTP status is going to now show a stratum level of 6. Again, clock is being synchronized with the reference, the time source being 127, 127, 11, which this is the router itself. So the router is being synchronized with itself, and this makes sense because a time source doesn't synchronize with other NTP servers. A time source just owns accurate time. So this is myself. Because how do I know that? Not only because that I know it should show up like that, the output, but because the fact that the 127.0.0/8 range, it is reserved for loopback address range. So there we go. That's in the range of the loopback, which means router 1 is synchronized with itself through a locally virtual loopback. If you go on the client, which is router 2, and you say show NTP status, likewise it says NTP not enabled. So let's go and say NTP server router 1, 10.1.1.1. Show NTP status. It's not as synchronized. Let's look at the clock on router 2. Show clock before it gets synchronized. Show clock on router 2 and on router 1, which is the NTP server. Show clock. So router 1, it's 21:00. The timing is on UTC January 28, 2016. That's on the server. On the client, it was 21:00:45. So the time difference was not that big. Show NTP status, and now it shows up to be synchronized, and the reference being the configured server. And as you can see, the stratum level shows up as 7, and this is expected per NTP design. So an NTP client is going to have a stratum level of +1 of the server's stratum level. So if the server has a stratum level, if the server has a stratum level of 6, its clients are going to have a stratum level of 6 plus 1, which is 7. This is basically like the hop count. How far away am I from the time zone, from the accurate time zone? Like for example, if you go in here and configure router 1 to be an NTP server, and router 3 a NTP client of that server, but also an NTP server by itself, and then router 2 to be an NTP client of router 3. If that's the case, this means that if router 1 has a stratum level of 6, then router 3 has a stratum level of 7, and router 2 is stratum level of 8. So this is like the hop count, but it has nothing to do with the number of routers or layer 2 devices between the client and the server. The stratum level on the client is going to say how close am I to the NTP server's clock or stratum level. Always a client which is always a client of a server is going to have a stratum level of +1, the server's stratum level. If you say show NTP association detail, you're going to see that the time source, it is being sane. It's our master, it's sane, but it's not authenticated. You don't see the authenticated keyword in there. So let's go in there and perform authentication. I'm going to go on router 1 and say NTP authentication key. Let's say 100 MD5, and then authentication key string is going to be NTP CISCO. Then you say NTP trusted key 100, and that's everything you do on the server. Now on the client, you go and you put the same two commands on the client, which is router 2. So both the key and the key string, they have to match. And then you say NTP authenticate, because the client has to authenticate the time source. So this command makes sure that all packets received from the NTP server are going to be authenticated. And then the last thing to do is do show run include NTP. You configure the NTP server saying, when you speak with that server, I want you to use key number 100, which means to use that specific authentication key string, which means from the key number and from the key string and from the NTP packet payload, put those in the MD5 hash engine and create the MD5 hash. So while this is gonna get synchronized back and forth, so what happens is when router 2 sends an NTP request now to the server, so when router 2 sends an NTP request to the server saying, I want to synchronize my time with you, NTP request, then in the MD5 hash engine, the router puts as input the packet payload, so the request itself, the key number, which in my case is 100, and the key string, which in my case is NTP CISCO. The result is going to be the MD5 hash, and that MD5 hash, it is going to be attached to the NTP packet. Let's see if it got synchronized. Router 2, show NTP association detail. So it still says terminal 1 configured. It still says our master sane, so I'm still synchronized, but now it also states authenticated. So that confirms that I got synchronized with the server, and I have also authenticated the time source, which is router 1, which is my NTP server.